In this video, I'm just going to give a very simple overview of what an even and odd function are. So I'm just going to give the definitions of them, basically. So an even function is basically a function where if you were to plug in a negative x, what you would get out is the same as the original function. Okay, so I'm going to give an example of what this is. And then also, an even function is symmetric about the y-axis. So you can easily tell if a function is even if you have the graph. But let's go ahead and just give a very classic example of this. So f of x equals negative x, or sorry, not negative x squared, but just x squared. Okay, so f of x equals x squared. So this is a very classic example of an even function. So most of us know what x squared looks like on a graph. Okay, so if you don't, this is the way it looks. It looks like a parabola. Okay, so it's symmetric about the y-axis. You know, if you were to fold it on the y-axis, you should get the two lines matching. You know, if the drawing was better, you may be able to see that better. But, you know, it's symmetric around the y-axis. So you could tell just by the graph that this is an even function. Also, if I were to go ahead and try this out where I plug in negative x, so I'm going to go ahead and do that. If I were to say f of negative x, what would this equal? So I'm going to plug in negative x into the function. And then f of negative x, so then this negative sign, you know, it's getting squared, right? So anything that's squared, though, is going to be positive. So it's the same thing as x squared, right? Because it's to an even power. So negative x squared, same thing as x squared. Oh, well, x squared is the original function, right? So x squared is f of x. So there we go. We have negative f of negative x equals f of x, which is this criteria here. So this is how to show it algebraically, and then this is graphically. So this is an even function. Okay, so now let's talk about what an odd function is. So an odd function, when you plug in negative x, what you get is the negative version of the function. Also, when you graph an odd function, you find that it's symmetric about the origin. So it's not symmetric around the y-axis anymore, now it's symmetric around the origin. Alright, so very classic example of an odd function is f of x equals x cubed. Okay, so what does this look like? What does x cubed look like? Well, it looks like this. Okay, I'm not very good at drawing, but like that, something like that. That's the way x cubed looks like. Alright, so, you know, if you were to, so you can tell that this is symmetric around the origin. The way I always say, so if you were to fold the paper here on the x-axis and then fold it on the y-axis, maybe you can visualize this, that if you fold it on the x-axis first, then that would bring this down here. And then if you were to fold it on the y, it would bring this on top of this, so then they would be matching. So this is symmetric around the origin. If you were to show this algebraically, so you would go ahead and plug in negative x. So you'd have negative x cubed. Okay, so f of negative x is the same thing. So now if you could pull out that negative sign because you know, negative that has been negative 1 that's been cubed is still negative. So this is the same thing as negative x cubed. Okay, so